All right, so almost as hot as Rust, or maybe more hot even, depending on your point of view, is gradual typing. But how is gradual typing actually used? What we're going to learn today about a corpus study or towards a corpus study, I guess, of the dynamic gradual type and how it's used. The talk will be Dibri and Nsofor, with Ben Greenman as a co-author. Next year we can have a workshop on human aspects of presentation software. Important work to be done there. All right, please go ahead.
Hello everybody, my name is Dibri Nsofor and I'm with the Utah PLT group from the University of Utah. Today we're going to be sharing an idea exploring a gradual study on the dynamic type, or a corpus study on the. Hi everybody, my name is Dibri Nsofor. I'm from Utah PLT at the University of Utah, and today we're going to be sharing an idea exploring the corpus study of the gradual type. For the longest time, as an industry, we've been split between two camps, one who prefers dynamic typing and another who prefers static typing. And slightly over a decade or so, we began exploring some middle ground between the two, some way for us to be able to leverage static types that we write for some guarantees, but still preserve the flexibility that dynamic typing offers. And as an industry, we settled on gradual typing. And developers seem to love these types. We've seen them show up all across the landscape. TypeScript, for instance, having over 19.6 million repositories on GitHub that use it. And for the most part, all of these languages, because they cater to different host dynamic languages, they all differ in some way or the other. But the one underlying feature for all of them is that they have this special type called any. And essentially what any is a top-level type for possible types in each of these languages, such that if typing becomes too restrictive, developers can opt for the any type. And you may be wondering why this is important. Say we started off typing this, or incrementally adding types to this program, and we ported over a statically typed system like OCaml. It would be impossible for us to return or reason about what the return type of this function should be, since OCaml has no notion of tagged unions, because in this case our function returns both a string and a float. And so in such a case, the any type would be a perfect type to adopt. But as you may notice, our print statement on the last line could result in a malformed result, such that any introduces some imprecision, meaning that now that we've ported over our statically typed language and introduced the any type, we've weakened the analysis we make with our type checker and we're unable to flag the last line. Just to hammer this point in, say I were working in some type library and I depended on another type library, and somewhere down the line we depend on some untyped code. The imprecision could bleed all the way to the top, such that even though we have some checks or some guarantees about the code we're writing, we could still run into runtime errors for trivial issues. In this case, the type library makerec or the function fails to account for the fact that getURL may return an error object as opposed to one that has the JSON attribute. And so as we've seen, any's can be a blessing and a curse. So we want to limit as possible how often these show up in our code base. But when we look at source code or gradually typed source code, we find that these any show up everywhere. For instance, with mypy, we find across 221 projects, we find 320,000 signatures that contain the any type. And it begs the question, how do we design these languages? How do we end up with languages that have more precise typing options so developers have to opt less for the any type? But before we do that, we have to look at the current options to designing these languages. So the most common approach, like the one we highlighted earlier, is to take some notion of types, say from a textbook like TAPL, and merge that with the dynamic type and hope that's sufficient enough. But as you can reason, just like with our earlier example, it'll always be impossible for you to end up with a type system that's exhaustive enough to reason about the dynamic languages, idioms. The second approach could be the one TypeScript takes, where you put together or assemble a group of smart people who have some idea of or good experience with the dynamic language at hand and have a good understanding of type theory and hope that you come up with something that's useful and works. But there's a lot of room for errors here. There's a chance that the language becomes too strict to where it doesn't even, or essentially the semantics between the dynamic language and the gradually typed counterparts differ. And so both approaches have some limitation, and we want to find a way to get towards more precise typing options, regardless of which one you take. And so since these any show up, our idea is to look at how these any show up or see the path that developers are treading with the any type and suggest more precise typing options. So if we were to look at our earlier example with our understanding of type theory, we could suggest some more precise typing option here, and now we type check and we're able to flag the error in the last line. So that's essentially our idea, to adopt some notion of data science so that we can study how these types are used and offer more precise typing options. So over the course of this talk, I will present our approach towards designing a corpus for our study and 6 patterns that we noticed like this that show up in mypy code. So the big picture here is essentially to take 79,000 Python repos or repositories we know that concretely use mypy and apply them through some automated analysis, and hopefully we can end up with data points or points that language designers can focus on to improve the language. While we do understand that stars may not be the best metric here for assembling a corpus, that's the approach we do take. But before we can get to our automated analysis that's able to punch out all of these points, we take a sample of these repositories and manually study them, hoping that this corpus would be somewhat reflective of like the behavior that shows up in the Python community at large. And so from this corpus, we filter out all of the signatures that have the any type, and then we employ our team of language experts to study these types or study these signatures. And essentially what this study looks like is we have some type signature or stub, and then we look at the source code counterpart and we ask ourselves, why do the any show up? Does it express some pain points that the developer is trying to express, or is this them trying to transition from untyped code to typed code? And so for this, we take a random approach to this, or a random sampling approach to this. One of the authors goes over 30 projects and studies 92 signatures, and another goes over 10 projects and goes line by line down to 5,000 signatures. Moving forward, our focus shifts to mypy from gradually typed languages as a whole. So essentially what mypy is a static type checker for Python, meaning that you can, based on the approach presented in PEP 8.4, you can annotate Python code and have it give you some guarantees about the code you write. While mypy does offer some precise typing options, it does also allow you to implicitly introduce weaknesses into your code base, even when developers may not be aware. So like in both of these cases, developers using a type variable and has a function that returns some list of type T. But in this case, mypy implicitly infers any as the type of this function. And in the second case, there should be an error raised since the developer is defining the variable data with none, but they ignore it, and mypy doesn't raise further errors concerning that declaration or definition. So moving forward, we'll present the patterns that we noticed. For each of these, we'll share the problem, or I'll share the problem. I'll share what our proposed solution is, and then our approach towards flagging this at scale. And we're hoping that during the course of this discussion, if for all of the patterns that we don't know how to flag at scale, that we can sort of employ all of you guys to help us fix that. And then for the guide for how to read both if it has the green tick, it means mypy already has a solution for this. If it doesn't, it means mypy doesn't. Yeah. So the first pattern of interest is one where developers use the anytype in places where they try to return instance objects. So in this case, we have a move method that returns an instance object, but it's typed with the anytype. And essentially, this introduces imprecision down the line. So when we do call the move object with for, now mypy is no longer aware of what objects are at play here. And so moving forward, mypy can offer no typing suggestions even in the IDE. And so to solve this, thankfully, mypy now comes supported with a self-type, and so we suggest that developers do go for that. Essentially, to flag cases like this, we just, to flag cases like this, we look out for methods that return instance objects by type, if any. Our second one is one where developers try to model dependent dictionary style behavior such that they know, or because of the nature of dictionaries in Python being heterogeneous, using any as the value type of these dictionaries offers some flexibility, but developers concretely could know what the counterpart value types should be. So in this case, price, or we calculate the discount of some item. But when we use values in this dictionary, we introduce imprecision with type analysis. Here's a similar case, but in this case, because I guess there's some relationship between the key K and our config dictionary, and that's not immediately clear because of some limitations in mypy. And so in a case like this, we would suggest some type of index access type option so that the relationship is immediately obvious. And to flag cases like this, we just look out for mapping types that have any as a value counterpart type. Our third case of interest is one where, or pattern we noticed is one where developers opt for any in places that clearly, or could clearly need type variables. So in this case, we have a function that compares two values. And essentially, while this could be the developer's intent to genuinely compare two variables, or two values, Python will not raise an error if you try to compare a string and a number. So it will return a Boolean value. And so if the developer's intent is to preserve some consistency about the types of these parameters, then using type variables would be best here. This is a similar case where we have a function that zips two lists into a list of tuples. And in this case, the relationship between any of the parameters or the parameters and the return types are not immediately obvious, and that's something that using type variables would be able to afford us. And so in cases like this, we just flag type variables and we monitor how they're used across the code base. In cases like this, we suggest using type variables, sorry. For this, we're not immediately sure how to flag this. Our suggestion or our current consideration is to replace each of these cases or each of these any types with type variable options and try to unify the types later. And if the types do unify, then we can replace them with the same typing options. And if they don't, we can still keep the separate type variables. And hopefully that should be able to preserve some consistency. I don't know, does anyone have any better approaches to flagging this? Let's wait for the answer. All right, okay. And then for this one, we have cases like the one presented earlier where we have an unconstrained type variable. Essentially, on the last line, our definition or our call to count cars instantiates our type car with both a string and a number. And mypy is not raising a type error here, or doesn't raise a type error. And in a case like this, it may not be or this behavior may not be intuitive to developers, and so it will be good for mypy to raise some error here. Our suggestion here is for developers to use type or to bind these types to some types or overset types. And to flag this, we look out for unbounded type variables. Our next pattern is one where developers try to implicitly weaken mypy's type analysis with type ignore statements. So here we have a subclass that overrides a method right. And in this case, the arguments of the parameters become less general, and mypy wants to raise a type error, but the developer knows that this is somewhat behavior that we're willing to account for and ignores it with the type ignore comment. And they weaken mypy's analysis by introducing an implicit any on that line. So moving forward, our suggestion would be to analyze each of these cases where we find this type, and if they do trend one way, like if developers want contravariance or covariance as a preferred typing option, then mypy can preserve that, or it can ignore them by default. To flag this, we just look out for the type ignore comment. And our last case is one that acts as a kitchen sink for all of the other typing or all the other cases of any's we find. We have this function that essentially should does an implicit return, and developer opts for the any type as opposed to using none. In this case, our suggestion would be to employ tools like monkey type, something to replace cases like this with like more precise typing options. And to flag this, we're not exactly sure, since this case essentially acts as or is too vague for us to narrow it down. Maybe using tools like monkey type should be enough, and then we just replace all of the typing options we can with more precise types, and just let the other ones be. So the goal here is to finish up with the automated analysis and apply it to our 79,000 repositories, and then we can find data points to improve gradually typed languages like mypy. And so we identified 6 of the 8 patterns we noticed in the paper, 3 of which we have design analysis for, and 3 we need help with. And so our ultimate goal here is to be able to offer more precise typing options, better tooling from mypy, and if the types or precise types do exist, some way for developers to know that they exist. So better documentation for them. So yeah, irrespective of which path you take to designing a gradually typed language, we hope that leveraging some notion of data science should be able to help improve the language. Thank you.
All right, thank you. Do we have questions, comments, suggestions, since you asked for them?
Yeah, you found some pattern of usage of any, and some of those patterns are easy to fix. By fix, I mean replacing any with more precise type. Do you have a sense of what's the motivation of using any for those programmers? Why did they use any rather than the more precise version?
I mean, the obvious one, or the one I'd hope that's happening, is the reason for these any showing up is that people are transitioning from untyped code to typed code. But more realistically, I think it's just more convenient for some of these people to just, since they have some tests, to just use the any type to silence all of the IDE errors.
Thank you.
Can you go back to the slide with the bytes IO example? Yeah. So this one I find interesting because I believe the person who implements file opener and it says it ascribes to this interface, but then it doesn't, right? They're just, like, that person is wrong, and giving them any escape hatch to just say, like, well, I'm going to say I implement this interface and then just sort of like cover up my work with the any type or type ignore or something. Like, I wonder in these kinds of cases where somebody's like, well, I just don't want to handle the case where somebody gives me a byte array. I don't think anyone's going to do that. Like, it seems, for instance, maybe part of the issue is you need a way of like manipulating the interface you're implementing. Like, what you want is not the ability to say erase this type, but rather update the binary IO interface such that, like imagine a sort of, I don't know, like a query language where you'd say, like, select the right method from binary IO and replace the type union bytes array with bytes or something. That's just sort of a suggestion, but I'm curious if you all have thought about anything like that, about rather than just like sort of like overriding the intention of the person who wrote the spec, are there ways you could like make these sort of surgical updates to a spec or like a type you're claiming to ascribe, such that then this would be well typed?
Yeah, I think that makes sense.
Yeah.
Right, so this is allowed by default in TypeScript. You can just do these covariant overrides.
They're just wrong, right?
Are they just wrong? I don't know. So they're doing it anecdotally because developers want it. So what we're really trying to do here is figure out what is the shape of the world. What are developers actually doing? And then we can talk about what's the right solution for those, cow paths in the grass.
Yeah, so I wanted to weigh on this as well, and I get what you're saying, Will. It's like from a static type design perspective, it's absolutely wrong, right? It's unsound. But I think the challenges that, what I've seen and what your comment is really referring to is that these gradual or optional type systems are not always designed with the same criteria as static type systems are designed with, right? And it is very intentional to allow this sort of thing, certainly in TypeScript. And it's not, so I think it's wrong if you're designing a static type system from scratch. If you're dealing with a ton of existing code in a dynamically typed language and you want to create a developer experience that finds more bugs but does not try to be sound in the sense that static type systems are, I'm not sure that's the right design philosophy, right? So anyway, I know this is probably something everyone in this room maybe has a different opinion on, but I wanted to throw that out there. I think this is a legitimate design dilemma. I think you had your
question. I'm curious, how often do you see any type in those code bases, and what is the distribution of these patterns, and how many usage of the any types are not covered by one of those patterns?
Oh, okay, that makes sense. We don't have the numbers for all of that yet, but across the tiny corpus that we do look at, we find over 320,000 occurrences of the any type. But we don't have them spread across each of the patterns that we do find.
So since you're looking at Python, you're working in a context where you have a language that is historically dynamically typed and then you're applying static typing to it. But as you introduced earlier, there are sort of two paths to this, right? There's the other path of you have this full static system and then we're introducing gradual typing in that context. There are probably more examples of code where it goes the first way than the second way, but do you think that it would be worthwhile to look at the same sort of question going from the other direction? Like, would developers have a different experience if they're used to static typing and then introducing dynamic gradual typing in that context versus if you're used to dynamic typing and then you're introducing static typing?
I mean, I guess it would be interesting to see if a developer who already has prior experience with static typing comes to or is forced to use the any type when they do adopt gradually typed languages, because that could definitely highlight pain points. But I don't see why they would need to opt for the any type if they already have good understanding of type systems.
I really like what you've done here with compiling this corpus of example uses of any. In terms of solving these issues, it feels like it might be pushing the limits of what you can do with formal methods, and I'd be really curious to at least have an LLM baseline where you kind of take some of, take some of the examples you've seen in the corpus, correct them by hand, and then pass in like a few example pairs like these to a model and then see if it can find other instances. Because, for example, it might help with some of these like, oh, like in this case, really the deeper issue is that the developer didn't want to handle this case, and really the proper way might be to introduce error handling for the other case rather than a more mechanistic like, oh, replace this type with this other type thing. And it's, I wonder to what extent models today are able to make those types of corrections once they've been kind of primed with some of the examples that you've uncovered in the corpus and some of the patterns of issues you've uncovered.
I guess just using languages like Luau, which is Roblox's variation of or gradually typed language for Luau. In the Roblox IDE, it does offer code assist, and from what I've noticed, the typing options that that suggests are almost always wrong, just because with gradually typed languages, these types are essentially, or like with erasure types in this case, they're essentially commons. And so you're putting a trust that the people writing this code know what they're doing. And that's just not the case with gradual typing. So most of these tools end up suggesting the wrong type.
Yeah, that makes sense. I guess that's why I'm curious if you feed in some of the examples you have from your corpus, if you see model, like you might see a drastic improvement in performance if you do that, or you might not. And that would be interesting, right? And sort of, if it doesn't work, right, gives you a very strong narrative that like, oh, we need to apply formal techniques to this problem because like models are incapable of doing this, right? On the other hand, it might not be that hard to try, and if it works, like, boom, you have a great solution to like changing some of these problems. Yeah.
I guess that would work for all of the cases where, well, that could be interesting for all the cases where mypy does offer typing options or precise typing options.
Yeah, thanks.
So sort of along the lines of something I said earlier, like the corpus will tell you what is, but it won't tell you why it is what it is, right? And so I wonder if there's an opportunity here for looking at the history or doing an observational study, watching people write annotations, watching people write code and try to understand, like, why did somebody do this? You know, were they trying to save a little bit of time here? What was the what were the perceived risks and benefits? Because maybe if we understood more about why people do what they do, then we can have a better chance at building tools that are more likely to be successful for them.
Yeah, that makes sense. We have discussed doing observational studies on developers and watching them go from untyped code to typed code, or trying to fix or resolve errors that show up because of the type checker, to hopefully see if they opt for the any type or how hard they try to like find precise typing options. But we haven't done that yet.
Thanks.
To go off of what you were saying, I've actually experienced that exact situation during my day job, where for reasons I still don't know, the author of the library actively was breaking the invariant of the type for the sake of backwards compatibility with other libraries that he had. And so I would have to, I went through the process of messing with the types within our code to fit it like this, but the real problem was the fact that the library that we were using actively wasn't typing it correctly.
That makes sense. I don't know. Do I respond to that? I mean, I can.
Okay. Okay.
So I was, just to follow up, I got scooped in the large language model question. I was just going to ask if you thought about, if you wanted to scale this up. So all of these patterns were found manually, right? Like y'all reviewed code and you applied human into understanding, right? So if you wanted to scale this up in the kind of data sciencey way you're talking about, have you thought about or considered like literally throw an LLM at any type you find in a Python code base and just say, LLM, why do you think that they used an any type here? And then get 100, get 300,000 explanations and say, LLM, summarize the most common explanations given by LLM, and then see what you get out. Do you think that might work? Have you tried anything like that?
We haven't, but that would be interesting to explore.
I would love to see that happen.
So I had a question. It seemed to me that you had a couple of different kinds of patterns here. Some of the patterns, it looked like, and you correct me, maybe you can confirm or deny, but it looked like some of these, you can make a suggestion and it's always right. You should just always do it, right? It's always safe. It's always improves the type checkability of the code base. And then there's other cases where it's heuristic and maybe there's more than one solution, but you have maybe suggested the best one, or maybe you're still trying to come up with the best one. Is that, does the space divide like that, or is it more complicated?
I guess so. I mean, sorry, just to recap, you're saying there are more suggestions for language designers depending on how people see or view these any types?
Well, I was thinking that, so you're making suggestions about, when you see this pattern, do this, right? It seemed to me that at least some of those cases are always something you should do. Like it's always correct. It's always a correct and improving. It's always a suggestion that would improve their code. So you could just write analysis that does it automatically and everyone would be happy, right? Is that actually the case, do you think? And then there may be some others that are maybe people would want to look at before they apply a suggestion?
I think for the most part, for the ones where we do suggest more precise typing options that mypy does offer, I feel like just plugging, or with my experience, just plugging the more precise typing options has worked.
Yeah, okay. I'm just thinking that might be an interesting lens to, like if you do the full corpus study, you could maybe say, oh, here are the guaranteed wins, right? And here are the ones where there's a heuristic maybe that would be helpful, but some choices to make for programmers.
Yeah. Okay.
Any other comments, questions? All right. Well, thank you so much. Yes.